Hello, and welcome to an episode of Your Prescription for Tech Nonsense. If you're like me, at some point in your life you decided you wanted to build a gaming computer. You turn to the big tech YouTubers and you listen to their recommendations. They tell you to buy components from trusted brand names like EVGA, Corsair, Seasonic, etc. But you realize these things are out of your budget. Maybe your used market isn't fantastic. So you turn to good old friendly eBay and Amazon, and you start seeing brands that you've never heard of. But you think, wow, this fits my budget. Hey, maybe I'll try it out. The goal of my video is to buy as many sketchy components to build a brand new gaming computer, and in the end see if we have a working system, and if this is something that I would recommend to brand new builders or other people that are just looking for cheap components. So stick around and let's see. As not every component can necessarily be off-brand, I was going to purchase a Ryzen 5 8400F from AliExpress, a marketplace that can have variable seller quality for the heart of this build. However, given the tariffs, which were even higher at the time, this CPU, which normally ranges from $80 to $90 on AliExpress, was almost $180 at that time. Since this video is supposed to be a cheap way to get into a relatively new gaming computer, I ended up scouring the used market and purchased a Ryzen 5 7500F instead. This ran me about $150 and only saved me about $8 from one that was brand new, which is not exactly a worthwhile trade-off. Moving on to RAM, here is our first sketchy brand. You may have heard of Kingston, but I bet you've never heard of King Bank. This RAM had all of 3 reviews on Amazon at the time I purchased it. It is a 2 by 16 gigabyte DDR5 kit for a total of 32 gigabytes, features speeds up to 6000 megahertz, and has a cast latency of 36. Brand name RAM with similar specs runs anywhere from about $30 to $50 more than this, which raised some huge red flags for me, so of course I had to buy it. Now, in automotive terms, this is roughly the equivalent of buying off-brand RAM. For storage, I scooped up a 1TB PCIe Gen 3 M.2 SSD from everybody's favorite brand, Neatac. This features 3D NAND technology and boasts read and write speeds up to 3000 megabytes per second. The opinions I found on the internet is that Neatac drives fail and they fail often. So of course, I had to buy it. I think the biggest and most often repeated piece of advice I hear from tech YouTubers when it comes to building a PC is don't cheap out on your power supply, which to their credit, a bad power supply can make your system misbehave and even ultimately destroy other components if it can't handle the power load it is supposedly rated for. So that's exactly why I bought a Sigatep 650 watt gold rated power supply. The closest price I could find to this from a name brand model was from MSI, and it cost $10 more with an efficiency rating of only bronze. What really piqued my interest with this certain power supply was the thousands of positive Amazon reviews making me think, can this sketchy power supply really be that bad? Well, I guess we'll find out. Given that I bought a used CPU, I managed to find myself in the situation where I have no stock cooler. So I turned to Amazon to see what I could get out of one of their cheapest coolers on the site. Thermalright may not necessarily be a sketchy brand, but this whole combo only costs $17 and comes with the cooler and thermal paste. So we will be testing if both the cooler is worth it and you can get away with the supplied thermal compound. While I couldn't necessarily find an off-brand motherboard, I decided to buy the cheapest used model I could find on eBay that included some heat sinks for VRM cooling and built-in Wi-Fi. This MSI Pro B650S Wi-Fi was supposedly checked for function, but only time will tell. For the graphics card of this system, I am using a card I previously purchased, which actually became the inspiration for this computer build. This Maxwell-based GTX Titan X is now 10 years old and is the most powerful card that NVIDIA produced that still featured a dual-link DVI port with true analog signal output. These cards can be had for around $130 today. While it's been a decade since their release, they still boast enough power to play a lot of modern games in some capacity, but we're starting to see games requiring features that this once flagship just doesn't have. Now I know this is not a sketchy brand, but building with decade-old components can have its own issues and could be reflective of a first-time builder's experience. The last piece of our system is the case, from the brand Okanos that I've never heard of. This specific model is the Cypress 5 Air, and the reason I bought it is because it reminded me of my Corsair 4000D case that I love so much. except it is about $40 to $50 cheaper. The last time I bought a cheap case, it was a nightmare experience to build in, so we will have to see if the quality of cheap cases has improved at all. This case features a glass side panel, four 120mm case fans, two USB 3 ports, and USB C at the top of the case, but most importantly, a mesh front and top for optimal airflow. Part of the problem I've had in the past with buying used or off brand components is that it leads to a, I guess, how should I say it, less than optimal building experience. So we will see how that plays out here. The first thing I checked with my motherboard was to make sure that there were no bent or missing CPU pins, as the rest of the board looked alright. There was a weird reflective area in the socket, but it didn't necessarily raise any red flags. Now, one of the biggest downfalls of buying a used motherboard is not getting the appropriate accessories with it, and this not being disclosed. This motherboard did not come with an I/O shield, which is not super uncommon. However, I have had motherboards in the past not come with a backplate or mounting bracket, making it almost impossible to mount a CPU cooler. So that's definitely something to look out for if you take this route. As you can see in this video, I did a quick check of the CPU to make sure nothing serious stood out, such as thermal paste on the metal pads. If this was present, it could block electrical circuit or cause the circuit to run to the wrong pins, depending on what thermal paste was used. However, this one looked clean, so I slotted it in. After that, I took off the stock cooler mounting hardware, as I knew the new cooler would use its own. At this point, I decided I was going to seat the RAM. I made sure I followed the slot pattern on the motherboard recommended by the manufacturer for a dual channel setup. Now, what I will say about this RAM is that it came with nice metal heat sinks and slotted perfectly into the motherboard. Supposedly, this RAM works with both AMD Expo and Intel XMP, so theoretically it should work with our build. Of note, if this RAM causes any issues with posting, it might be harder to diagnose since I don't have integrated graphics in this CPU. Moving on to the SSD, really nothing too special here regarding any issues with placing the drive. Just remember to remove the plastic from the heat spreader before you place it back on top of the drive, and to use the appropriate screws to secure the drive into place. As I started getting the CPU cooler ready, the first thing I noticed was the substantial weight of this model. I have previously bought other brands and models around this price point, but this model from Thermalright feels the most substantially weighted to me. Given more metal generally equals better heat dissipation and cooling, I have high hopes for this budget-friendly cooler. Now, it seems like it should be a no-brainer upgrade over a stock AMD cooler, especially since they generally sell for $10 to $12 online with shipping. So the additional $5 for a tower cooler might be the best low-cost upgrade you can make to a system. It seems every YouTuber has a specific thermal paste that could save you maybe 1 degree on your CPU temps, but some of those cost half as much as the entire Kohler setup I have here, and this came with supplied Thermalright TF4 thermal paste, so in the spirit of the budget build, we will absolutely be using this and seeing how well it performs. I have read some reviews that claim it is too liquidy, but I personally found no issue with it, and since it's non-conductive, I'm already a fan. Now let's get into our off-brand power supply. I've personally never heard of Sigatep, but after some research, I found bigger PC YouTubers like the Toasty Bros use these power supplies sometimes, but I've also read opinions online saying this brand is garbage. Now that doesn't seem to hold up given the thousands of positive reviews I saw on Amazon, but hey, that's why I got it, to form my own opinion. I think one review that stuck out to me is that this power supply stinks. Like, isn't actually bad, but smells. So I guess we'll see. Now, this power supply should theoretically easily have enough wattage for our setup, given I'm using a 65 watt CPU and a 250 watt graphics card. So if it can handle this, I guess I should say, if it can't handle this, we will know it's not worth it. On first impressions, this power supply actually had a decent amount of weight to it. One of the telltale signs of a cheap power supply with a fake rating is if it feels incredibly light and cheap. This absolutely had the appropriate heft for a 650 watt unit. I gave the power supply a shake to listen for any loose components, which would signal a faulty supply, and well, I heard nothing. It was as solid as a rock. Now, one thing to note is that this is a non-modular supply, so all the cables are directly built in, which may not make it ideal for pristine cable management, But the supply did come with a jumper, which is a nice touch to be able to test the supply if it's powering on before putting it into your system. So that's exactly what I did. I set up the power supply to some case fans in an old case I had lying around to see if we had a working unit. And well, voila, we have working fans, which makes me believe this power supply will be fine for our build. Actually, placing a power supply in a dodgy case can be a hassle, as often there's not enough room for the cables themselves, especially if you're using a non modular power supply. And even worse, running the cables is a pain since the case has inappropriate or terrible cutouts. But honestly, this is not the situation with this Okanos case. It has plenty of room for the power supply and actually useful case cutouts. There are a few qualms I have with this PC case though. The first being that the top case and power supply vent have a dust filter, but the front of the case does not. The holes on the front mesh are larger than the other two areas and likely to allow in more dust. That being said, the larger holes should allow for better airflow. The second issue is that the case has a cheap feeling metal. This metal is fine, but definitely flimsy compared to the aforementioned 4000D case that I love. And the last qualm is that the GPU bay requires the metal flaps to be broken off to use. However, they do supply some slide-in replacements. Now, in my personal opinion, all of these complaints are minor, and I'd absolutely recommend this case to someone on a budget. Now, after some quick cable management, it was time for the scariest part of any new system: seeing if it posts. Brilliant. Absolutely brilliant. Future me knows you won't be saying that for long. After that successful boot, I decided to put Windows 10 on my PC since I already had a bootable USB stick made. All was going swimmingly. Following that, I updated the operating system and put on the motherboard and GPU drivers. I decided to upgrade to Windows 11 in order to continue to receive security updates, but that's where my issues started. Every time at about 79%, the system would just blue screen. Every single time I tried, I got a different crash code. Initially, I had an inkling that the RAM was causing these crashes, given the inconsistency of the crash codes. So I decided to turn on Expo to the max rated RAM speed and load up memtest86 in order to check for faulty RAM. Of note, these blue screens were happening with the base frequency of 4800 MHz, but I figured the higher frequency would cause the RAM to heat up more aggressively, and potentially cause more faults while testing. And of course, I had to run some Pokemon Platinum Battle Tower during this 3.5 hour test. But lo and behold, when the test had completed, the memory passed, and it did so with 0 errors, which left me perplexed. My next thought was that maybe the Windows installer was causing the crashes and I should try a fresh Windows 11 install from a USB stick. So off I went to make bootable Windows media. While the initial install failed, the second attempt was a success, and sure enough we were in Windows 11. But oh, the fun had just begun. Every single time I attempted to download and install Windows updates, I would get constant errors saying unable to install, and of course, you guessed it, blue screens constantly. So I thought maybe it was an issue with the compatibility of my hardware and Windows 11, since Windows 10 seemingly had worked fine before, so back to Windows 10 I went. My positive attitude was short-lived. As I was downloading and installing games, the system began to blue screen and every game install showed up with a corrupt download error. Oddly enough, once the files were re-verified, the games I played were all stable, as you can see here with some footage I captured while I was playing Rocket League. So I had the thought that all these random errors were occurring during my downloads and installs, but not during my gameplay, so maybe it was my trusty MeTAC drive that was bad and not the RAM. However, I still wasn't fully convinced, so I tried one more RAM test, and well, I got the same results as before. The RAM showed no errors, so on to testing my SSD I went. So my initial idea was to replace the SSD with a hard drive that I knew was working, and see if we could download Windows 11 without any blue screens. And well, here we are back at the Windows Update Center, and this is where the computer tends to crash the most. So with our 1,000-year-old hard drive, we're going to go ahead and see if it can actually survive the download and the install. And if it does so, then I know my other drive is definitely cooked. So, while I think the extreme slowness of my Jurassic Age hard drive prevented any blue screens, I was still getting failed installs. So, I decided to place my NETAC drive in a different computer that I knew was working and install Windows 11 on it. And yeah, it worked fine. And Crystal Disk found no issues with the drive either. Now knowing my storage drive was fine, I almost guaranteed the King Bank RAM was causing the onslaught of my issues. Who would have guessed? So I made a quick trip to my local Worst Buy and purchased this 32 gigabyte kit of 6400 megahertz CL36 Corsair RAM, which surprisingly was on sale at that time. It was also what was available, which is why I went with this set. After last time, with the same issues we were having with downloading and installing on the hard disk, we are back now with the new Corsair RAM installed, and we will see if we have those similar issues. My suspicion is that the issues will likely go away. I think the King Bank RAM was what was causing all of the issues to begin with, but I guess we will see. This screen here really is the moment of truth for us if everything downloads and installs correctly. Um, so we'll just have to wait and see. And at this point, I almost cried tears of joy because Windows updated appropriately and I was able to move into installing the chipset and network drivers for the motherboard. Mind you, this came after 2 days of me trying to get this PC to work correctly. So I'm going to try to do my best job of recapturing the next issue that I ran into. And I had my computer here set up to my secondary monitor via HDMI, like I have it set up now. And interestingly enough, whenever you turn this computer on, connected to the HDMI, you will see we really don't have any issues. So I'm going to go ahead and turn it on now. So give it a second. And you can see we get our BIOS screen here. No issues. And eventually we'll get into Windows 11. Now, in my haste, once I got the computer working, I had moved this computer from my secondary monitor onto my primary monitor, and my primary monitor runs on, I guess it uses, or at least I have it set up for DisplayPort. So I switched over from HDMI to DisplayPort and actually unplugged the HDMI from this monitor. So I'm going to go ahead and switch over to DisplayPort now and show you how or what the difference is whenever you're booting this computer from DisplayPort versus from HDMI. All right, so now I've switched over to DisplayPort, and I'm going to go ahead and turn the computer on again and show you the difference of what happens. So with the HDMI, normally I'd get the nice boot screen from the BIOS, but as you can see here, I've turned the computer on and essentially was getting nothing. And this was an issue because I was trying to get into the BIOS to adjust the RAM to run at the rated 6400 megahertz, the max speed that it could run at. But as you can see here, the computer was almost essentially going right past the BIOS. It wasn't getting this display output, which had left me a little perplexed. And I will say, part of the issue, and this is my fault, is because I decided, I'll go back to HDMI. Well, I apparently didn't plug the HDMI in the whole way, so whenever I plugged in the computer to HDMI and tried to turn it back on, I wasn't getting any display output, and it really made me worried. So I started digging in to try to find out what was going on. I was thinking, holy crap, is my graphics card, granted it is 10 years old, starting to die on me at this exact moment? But a little bit of research kind of helped ease my qualms or my worries. What I ended up finding was that Nvidia had previously released a firmware update for certain graphics cards that were experiencing blank screens on boot when using monitors with DisplayPort 1.3 and 1.4, at least until the system loads into the operating system. Now, this sounded exactly like my issue that I was experiencing. If you look on the supported products page, you can see that my Maxwell based Titan X quite literally is the first product that this firmware update applies to. Now, NVIDIA's recommendation is to update the firmware using their tool or use a workaround like using HDMI or DVI. So, when I plugged my HDMI back in fully, the BIOS screen started showing again, which confirms that I am an absolute buffoon. Now, I personally am not worried about updating the firmware since I plan on using this computer with a CRT monitor, which is why I cared about the analog output of the Titan X card in the first place. But nonetheless, I still wanted to increase the RAM speed to the max rated expo speeds, which is why I started this in the first place. So, into the BIOS I finally went. A few clicks later, I had the memory set to 6400 megahertz. However, when I restarted, I got a black screen that was unending. The motherboard displayed a solid orange light that did not go away either. And yes, I can confirm I gave the system time to do RAM training, but to no avail. The system wouldn't start. When I restarted the system, the motherboard produced a red and orange light signifying a CPU and RAM error. So, this is where I began to believe I had made an oversight. Per the motherboard specification page, it supports DDR5 RAM up to 7200 MHz in dual channel. But the motherboard isn't the only part of the equation. The CPU also has a max rated RAM speed, and a quick search reveals that the max rated RAM speed for this CPU is 5200 MHz. However, many people report that 6000 MHz works just fine with their 7500F, and we also know that my CPU was compatible with 6000 megahertz since that's what the King Bank RAM was running at. But 6400 megahertz was likely just too aggressive and not stable with this CPU. So here is where I went and returned the Corsair RAM and got a 32 gigabyte kit of 6000 megahertz CL36 Corsair RAM from Best Buy instead. Now, in my haste, I made an oversight that this RAM was only tested to support Intel's XMP and not AMD Expo, but I wasn't worried because AMD products can use XMP and my motherboard supported it as well. With the new RAM finally installed, it was time to see if the system supported the 6000 MHz speed of the XMP profile, and unsurprisingly, yes, it did. So after many days of toiling, I finally have a fully working system. Here is the final build. I know it's not going to win any aesthetic awards, but honestly, I don't care as long as it runs. Now sit back and enjoy some gameplay from my new system while I discuss my recommendations for buying sketchy computer components. So I think the biggest piece of advice I can give to a new builder or someone looking to save money is do not cheap out on your RAM. If you want to save money on RAM, attempt to see what's available on your used market. If nothing is available, buying RAM with slightly lower clock speeds or cast latency could save you a few dollars. Now, granted, I may have a few people come at me and say, oh, this opinion is stupid, but the few FPS you may gain from buying the world's fastest RAM with the tightest timings likely isn't worth the price tag for the budget buyer. That being said, when you're buying RAM, make sure you're buying it from a trustworthy company, not King Bank. Another piece of advice is to check your CPU compatibility with RAM and your motherboard's QVL or qualified vendor list for all the confirmed, tested, and supported RAM that has been used with that motherboard. This should guarantee you the best experience. However, if a set of RAM is not on that list, it doesn't mean it doesn't work with the motherboard. And I can attest to that, as all three sets of RAM that I used for this build were not on my motherboard's QVL list, and yet all three technically worked. But hey, it's not all bad. So let's talk about the things I would give a thumbs up and recommend. First off, buying used parts. The CPU, motherboard, and GPU were used and worked perfectly. I've bought a ton of used computer components in my life, and the vast majority work perfectly fine. All I would say is just make sure you test them while they are still within their return window, and also potentially ask pertinent questions like, is the motherboard BIOS updated before purchasing? The second thing I would recommend is the case. This case provided a great building experience. The four provided fans and mesh design provide fantastic airflow and keep all the components cool. Okanos has assembled a completely sensible case with a budget price tag. Truly, my biggest wish is that it had a front dust filter. But overall, I would recommend this case for anyone looking to buy one in the near future. The third thing I would recommend, which is likely my highest recommendation, is the CPU cooler. This $17 Thermalright cooler keeps my CPU exceptionally cool. Granted, this is only a 65-watt CPU. It could easily cool the 105-watt Ryzen 7 that I have in my other computer. And if you have a CPU that pulls more wattage than that, I would simply recommend stepping up to Thermalright's dual tower cooler design, which can be had for about $35 on Amazon. Overall, this tower and thermal paste that come in this $17 package are worth every penny and are a budget builder's dream. And if you don't want to take my word for it, you can simply look at the temperatures that are included on my gameplay. Granted, because there's a bit of a bottleneck, the CPU isn't even drawing that much power, but you can see this CPU is extremely cool. Now let's move on to my conditional recommendations. Firstly, the NETAC SSD. This drive has given me zero issues. It has worked perfectly at the speeds it has been rated for. I installed Windows on it so many times that I can tell you from the beginning to the end of an install, it takes roughly 4.5 minutes for Windows 10. Even though it's using a slightly older technology, this drive is fast to say the least. Now, the issue with this drive is I have no guarantee of its longevity. If you are just installing and playing games on it, it is likely perfectly fine. But given the comments I have seen regarding failure of these NETAC drives, I probably wouldn't store anything extremely important on the drive without backing it up somewhere else. The second conditional recommendation I have is the power supply. This power supply works perfectly in this system and has given me no issues. It easily runs a GPU that pulls over 200 watts of power constantly. That being said, I have some issues with the PSU. Remember how I said I read a review where this power supply smells bad? That person wasn't lying. When I turn the PC on, this power supply produces an odd plasticky scent that I've never smelled from a power supply before. It's not a burning smell, and I have no concerns regarding the scent. It is just present when the system is on. So if you have a sensitive nose, you may want to look elsewhere for a power supply. However, I will say the more I use the system, the less the smell seems to be present, so it might just be associated with its first couple uses. Now, the real concern I have with this power supply is that if it does break, will this company honor the warranty? From the reviews I read on Amazon, that seems to be questionable. So once again, I think this power supply is fine, but if it was me, I'd personally buy the MSI supply I mentioned earlier for about $10 more and avoid the scent while also having peace of mind, knowing if something breaks, you have a real company that will honor their warranty. So I wanted to give a quick shout out to those who stuck around and watched this video. I appreciate you being here. I hope you enjoyed the video, and I'm going to be trying to make more content in the future, but the videos do take me a little while to record and edit. I know the editing could be better on these videos. I don't have all the time in the world. The other thing is, I know this video probably could have been better had I used an AM4 platform. I could have got basically a motherboard from mainland China to test one of those, see how it does. But this was my own personal build, and I'm keeping this computer, and I actually wanted to move into an AM5 platform, so that was the reason I chose AM5. But like I said, I'm going to be trying to do some more content in the future, so if this is something you enjoy, I'd ask you to subscribe and come back, and I hopefully will see you in the next one.